Hi guys, in this video I'm going to be talking about ATP, which stands for adenosine triphosphate. Now this is a molecule which carries energy throughout the cell. Your cells, and all cells, plant cells included, use glucose for energy. However, the cell can't use glucose itself. So this molecule ATP is used to carry the energy around the cell. I'm going to talk briefly about how this happens, because when you look at videos for photosynthesis and cellular respiration, ATP comes up a lot. So we're going to get started. So as I say, adenosine triphosphate. So I've been a bit lazy and already done something here. Okay, now you've got your three parts to your ATP. You have your adenine, which you may recognize with DNA and RNA. Okay, this is this little thing here. You have a ribose sugar, which is here. Okay, ribose sugar, which again you recognize from RNA. And you have these three little P's here, which are drawn as circles. And each one of these is the phosphate. And because there's three of them, you get your your adenosine, which is here, triphosphate. Okay, and this is ATP itself. Sometimes when you see videos or textbooks, they will talk about it with its little chemical cousin that we'll come to in a minute. But I want to start with ATP because most of the topics talk about ATP and how that turns into the cousin and releases the energy. As I said before, this ATP stores chemical energy. Stores chemical energy. This is what ATP does. And it stores it in this little bond here. Okay, so this little bond here, turn that into an arrow. That little bond there with a lot of A-level syllabuses call this the phosphate bond. And that little thing is what the energy is stored from. So glucose gets transformed and the energy gets taken out of it and basically gets stored in here. Okay? So what happens is, to release this energy, this phosphate needs to leave. Okay? So I'll just get rid of some of this. Be a bit lazy again. So here's our ATP. I've said the parts. What happens is this little phosphate gets taken away, and when it gets broken off, it's that releases this energy, okay, from this area. Okay. Now we don't have adenosine triphosphate, we have a different molecule. We have a thing called, where's my, there we go, ADP plus PI. Okay, so this is no longer ATP, it's now ADP plus P. Okay, and this stands for adenosine diphosphate. Okay, so I'll just write that down. Adenosine diphosphate. Okay, plus, because the di is obviously these two phosphates, plus an inorganic phosphate, which is this. So we have two molecules when we talk about ATP. We have the ATP itself, which has the three phosphates and that chemical energy stored up. And then you have your ADP plus P when this phosphate bond is broken off, the energy is released. And these move around in cycles to stick back together, which stores energy, goes somewhere in the cell, releases energy, and so on. So, the cycle's quite straightforward. I'll be a bit lazy again. Make this a little bit little. Okay. And I know these videos are meant to be whiteboard videos, but it's a little bit easier when it comes to this. So we've got our ATP here, and when this energy gets released, we're going to have in this corner the ADP. Stop pressing twice. ADP. Remember, this is when the energy is being released, this is when the energy is stored. And the processes takes place, as I said, it's a little cycle that just goes two ways. What we have first, when we have the ATP, okay, this bond needs to be broken down. So an enzyme comes along called ATP hydrolase, comes along, and some water comes along, and it breaks that bond. And because that bond's broken, energy is released, as I said before. And what you're left with is your ADP plus P. This kind of reaction is called hydrolysis. You might come across this before because it's a common reaction, and it just means the splitting, which is what this means, the splitting of water. So splitting with water. So water's come in with the enzyme ATP hydrolase, broken this bond, this peptide bond, which has let this phosphate off and release the energy to where the cell needs it. Now you've got your ADP plus your P plus your P, okay? These now need sticking back together, so wherever it's gone in the cell, it does its thing, gets released, releases energy, and then it goes back down, and another enzyme called ATP synthase basically sticks this together. So ATP synthase adds the phosphate back on using energy from glucose, and then it'll be ATP again, and this can go round and round and round and round. When the phosphate is added, this is called phosphorylation. I'll try and squeeze this on. Phosphorylation. So the process of adding this phosphate back together is called phosphorylation, and it's done using ATP synthase. So just as a recap, you got your ATP. It's got the energy stored in it in this little bond here. ATP hydrolase comes along with some water, does a hydrolysis reaction which breaks that phosphate off, releases the energy. You are then left with ADP plus P. Your phosphate is floating around. There's no energy there now. It needs to go back. Glucose uses some energy, gets added on with ATP synthase, and that process of this being added on is called phosphorylation. That's it. Straightforward as that. Thanks, guys.